Good afternoon, everybody. My name is Ginger Ni. I'm a developer of the Vertica Geospatial analysis package. So this package enables you to perform geospatial analysis inside the Vertica database. So we all know the Earth is round, and the latitude and longitude data we collect are based on a spherical model of the Earth. So if you're flattening your longitude and latitude data to a planar space, it may cause a loss of information and may lead to inaccurate calculations and predictions. Today, I will show you how to perform geospatial analysis on longitude and latitude data without flattening your data. So in the first part of the session, I would like to give you a brief introduction of the Vertica Geospatial Analysis package. Then I will show you a real-world use case. We will analyze the hurricane dataset using Vertica. So nowadays, people are using geospatial analysis technologies in everyday lives. From search nearby restaurant on smartphones to navigating cars using GPS devices. So in each of those use cases on the line, you will launch a special query to perform the spatial analysis. So Vertica provides two geospatial types, allowing you to store and query spatial data. And we provide more than 65 built-in SQL functions you can use to analyze your spatial data in Vertica database. So because we are performing geospatial analysis inside the Vertica database, so we leverage all the advantages of the Vertica cluster platforms, such like parallel processing and partitioning, scalabilities, and other optimization features. So Vertica supports two spatial data types. They are geometry and geography. So what's the difference? In short, geometry is used to store planar data, and the geography is used to store spherical data. So in the slides, I showed two coordinate systems. So Vertica supports multiple coordinate system. It includes the picture. The upper picture shows two-dimensional Cartesian coordinate systems. So in this space, data are presented using x, y coordinates. So for those data sets, we can store them in geometry. And also, like spherical models of the Earth, it's a spherical coordinate system. So data are presented using longitude and latitude coordinate. So longitude and latitude, they are angular unit. So for those latitude and longitude data, you can store in the geography data types. So the geometry and the geography data typing in Vertica are compatible with the shapefile format as well as the WKT, well-known text data format, and the WKB, well-known binary data format. And also you can export data from Vertica to GeoJSON data format. So those data formats are very commonly used. Most of the geospatial analysis tools will support at least one of them. So it's very convenient to transform data between Vertica and other geospatial analysis tools. Vertica provides a bunch of built-in SQL functions. So they can be divided into two groups. One group is OGC standard functions. So those functions will be supported for most of the geospatial analysis tools. So we support most of the OGC standard functions. That means it's very easy to migrate from other geospatial tools, such like PostGIS to Vertica. And another group is beyond the OGC standard. They are prefixed with STV. Those functions are unique to Vertica. For example, the st_create index. This function will help you create a spatial index on your spatial data. And based on spatial index, we can get a good performance for geospatial analysis in Vertica database. Those SQL functions are very easy to use. You can just call them in a select query. And if the function returns a Boolean, then you can also use them in a where clause. So here I show the two very simple examples. The first example is pass and load data from a shapefile to a Vertica table. So you can use the STV shape source and STV shape parser, and combined with the copy command, you can load the data from shapefile to Vertica table. And the second example is to calculate the area on a valid spatial object. So you can just select the ST area on the geometry column from the polygon dataset where the geometry is valid and returns true. So Spatial Joins is a group of commonly used spatial analysis functions. So Spatial Join allows you to find all the intersected pairs of two sets of functions. So let's take a look at the picture. It showed a simple example. So in the top level, it's a point data set. So like you have point 1, 2, 3, 4, 5, 6. And in the second level, it's a polygon data set. You have polygon A, B, C, D, E. Then when you run a spatial join analysis, it will generate the third level. So you can see all the intersected pairs of point and polygon. So from the result, you can see like point 1 is inside the polygon A, and you can also see like polygon C include 2 points. So those kind of spatial join functions in place are based on in Vertica database are based on spatial index. So we have very good performance on spatial join operations. And in the use case later, I will show you we will use the st_intersect. It's also a spatial join function. So longitude and latitude data, so there could be different longitude and latitude data based on the different spherical model of the Earth. WGS84, nowadays it's a very commonly used spatial reference system. It's an industry standard when you model the Earth. And it's also the standard for the GPS devices. So all the GPS longitude, latitude data, they are all WGS84 longitude, latitude data. So what I want to mention here is Vertica support calculations on WGS84 system. So you just need to load the longitude, latitude data to the geography data types, then we can calculate on WGS84. So I will show you a very simple use case. So to calculate the distance between Boston and New York. So the table shows the longitude and the latitude locations of the two cities. Then we can call select ST distance. And pay attention to we are using the ST geography from text. This function will pass the well-known text data to geography data type, and we will calculate on the WGS84 coordinate system. And the result is in meters already. So to use geography data type, there are pros and cons. So if your data covers the globe or a large area, then when you do the calculations, you want to consider the curvature of the Earth. So because WGS 84 it's non-projected, so for distance calculation and the intersections, it's more accurate than you project it to a plane coordinate system. And the disadvantage is functions on geography is expensive, so it's slower than on geometry data type. So if your data is in a regional data, then usually we use the geometry data type. So in summary, the geospatial analysis package enables you to do geospatial analysis inside the Vertica database. We provide a bunch of built-in SQL functions for you to use, and they are very easy to use. And we support the WGS 84 coordinate systems. One thing I want to highlight is the geospatial analysis package comes with Vertica in the new release in Vertica 8.0, which means when you install the Vertica, you will have all those built-in geospatial functions. You can use them. And no extra installation or configuration are needed. They just automatically deployed on the Vertica cluster. So now I will show you a real-world use case. We will analyze the longitude and latitude data on hurricane polygons and also on the property locations. We will create a heat map to visualize the analyzed result. So in this example, we will do a point in polygon analysis to identify properties that fall within an impact zone of a hurricane. So the point data set we're using here is landmarks on the US East Coast. And the polygon data set we use is the Hurricane Bonnie in 2016. They are all public available real-world data. And then we will determine the areas most affected by the hurricane and visualize them in a heat map. So this is the result. So from this picture, we can see the white polygon is the hurricane impact zone. And in this time, we can see the North Carolina state, it has the most impacted properties fall into the hurricane zone. There are like about 14,000 properties fall into the hurricane zone. And for each timestamp, we create such a heat map. So along the time, we will have a dynamic visualize of the analyzed result. So now I will show you step by step how to do the geospatial analysis with Vertica. So first, the data set and the tools. So the polygon data set, we are using the Hurricane Bonnie in 2016. They are published in the National Hurricane Center. And the point data set, we are using the landmarks data set from the US Census Tiger database. So we will using the Vertica to do the geospatial analysis, and we will visualize the result in R. So the data set we download are longitude and latitude data, but they are in different spatial reference system. So the first step is we need to convert them to WGS 84. So We are using the open source third-party tool OGR to OGR to do the conversion. Then we just load the shapefile to the Vertica table. So we always load the shapefile to a geometry data type, but here we want to calculate on WGA64. So the next step is we convert from geometry to geography so that the follow-up analysis is in WGA64. So now we perform ST intersects. It will return all the intersected properties with the hurricane polygon. And we will group by the stats, different stats, and different timestamps. So we will using this count in our visualization to create the heat map. Then we can see the properties in which state are impacted the most by the hurricane. Okay, so the point data set in this demo is conclude more than 200,000 instances. So for each timestamp, we create the heat map, and the spatial join computation, it takes roughly 1 second on a 3-node Vertica database. So it kind of very efficient. So in this case, I export the result to a shapefile, then load the result shapefile to R to create the heat map and visualize it. Besides that, you can also connect your third-party tools to Vertica database through the JDBC or ODBC, and to fetch the result. So that's the final result. You can get the dynamic heat map.